Hello and welcome back to Mikey's Flightdeck. Today with the configuration of this EFIS panel. If your cockpit project is a little bit bigger and not only a single device, then it makes sense that you are planning your connections before you start the build. This is what I have done when I started my pedestal. I thought which panels could be connected to which Arduino, and so I have planned all the connections to the 3 Arduinos before the build. And I have also done a rough planning now for my whole glare shield. The devices in the Glarewings, the EFIS panels and the MCP will be driven by 2 Arduino Megas. And I have estimated how many connections will there be in the future, how many LEDs, buttons and so on. And then I have made a layout with all the multiplexers or shift registers I will need to drive all these devices. And here you can see the layout that is screwed to a wooden plate so that I can move it around easily. You can see the 2 Arduino Megas. There are the 2 PCBs where the shift registers are mounted on. The shift registers will be used to drive many LEDs with only 3 pins of an Arduino. And you can see 8 multiplexers connected to the 2 Arduinos. The multiplexers will help me to connect buttons to the Arduinos and save me a lot of pins. But we will come to all these advantages now in detail. Down here you can see my power distribution, which will provide the Arduinos with 5 volts and the backlighting of the panels with 12 volts. A good documentation is also very important to stay on top of all the things that are going on there and all these wirings. Here you can see a small part of my configuration sheet, which you can download from my website so that you can have a look into it and see how I have solved some of the configurations. I filtered the configurations to my Arduino C, which is the Arduino that is driving the EFIS panel of the first officer, which we will now configure. And you can see I have documented which pins are connected to the multiplexers here, and down we have all the devices, in this case many buttons, which are connected to these input multiplexers and the offsets and hex values I'm using for these devices. We have also the encoders down here and the configurations for the Glarewing of the first officer, because these devices are also driven by the Arduino C, and I have rewired them because when I started with the Glarewing many years before, shift registers and input multiplexers weren't supported by MobiFlight. Now they are, and so I can use them and save also some pins. Before we start with the configuration in MobiFlight, we have a look to the configuration in Prosim, which I have done before. You have seen the offsets and hex values in my configuration sheet, and it's very easy here to find all the places where you have to insert these values. You go to Config and Configuration, and then to the Combined Config tab. And to see all the values that we need, we can use again the search function insert EFIS, and you can see 66 configurations are left over. Remember, we have 33 connections per EFIS, and when we have a look in here, you can see we have configurations for EFIS 1 and down here EFIS 2. And EFIS 2 is the one that we want to configure now, so I modify the search EFIS 2, and now we have only half as many configurations left over, some switches and encoders. And you can see I have already inserted the offsets here. Mostly I'm using FSUIPC 8-bit unsigned offsets. So because I only need an on or off value, so only 1 bit of the 8 bits of full offset. The only exception here are the encoders. And here you can see I'm using a 16-bit signed offset. This is the kind of offsets which works the most for encoders. But keep in mind, when you're using 16 bits, this means 2 complete offsets. So you enter here the starting offset, 5370, but the next following offset, 5371, is also used. And so you shouldn't use this following offset for any other configuration. The same thing here for the next one, 5372. And this is also using the next offset, 5373. I'm always documenting in my connection sheet the last offset that is used so that I don't run into any conflicts there. Yeah, and this is all you have to do in Prosim. Just stay concentrated, insert your offsets, and then you're ready to go. I will again use this configuration video to dive again a little bit more deeply into the configuration in MobiFlight for all those of you who are new to this topic here. If you want to know more about some other configurations, feel free to watch other videos of me. I have shown everything I have done here concerning configurations. But the EFIS panel just has buttons and 2 encoders, so it's not too complicated. I will show some configurations as an example and then moving fast forward so that it is not too boring for you. Another interesting topic is the reconfiguration of the Glarewing, and there you will learn some things again about shift registers. But everything starts up here in the MobiFlight modules tab. There we have a look to my only connected Arduino, the Arduino Mega, Arduino C. And here you can see the configuration, how it is currently done. Every LED of the Glarewing and the 3 buttons are single devices, and they are all connected to several pins of the Arduino. This is how we have done this in the past. Now we will do this in another way. And the first thing that I will do is removing all these devices. And this is because we will control them not directly anymore, but through a shift register for the LEDs or an input multiplexer for the buttons. And I start adding a shift register here. Let's have a short look to the configuration file again so that you understand what I'm doing now here. I will now configure an output shift register. For this output shift register, I will need 3 pins of the Arduino, and they control latch, clock and data of this register. There are 2 shift registers cascaded because with one of these devices I can control 8 LEDs. I want to control more of these because when I think of the upcoming MCP, I will need more LEDs to control. And so I'm making 2, there you can see it, 2 segments. Yeah, and MobiFlight is then calling the several pins of the output shift register 0, 1, 2, 3, and so on. I'm giving numbers to my shift registers. In this case, the next upcoming register is the output shift register 5, or short written OSR 5. And so I'm naming the pins where the LEDs are connected. Up here you can already find the values that I have talked about, latch, clock and data, and the pins are already right, 4, 3 and 2. And these are 2 segments that I have. I'm entering the name OSR5. And the next device is the input multiplexer. Again, let's have a look to the configuration sheet. Up here, we'll find all the information that we'll need to configure the multiplexer. A multiplexer needs 4 connections to your Arduino, and they are called S0 up to S3. And I have already chosen pins that I will use for this. So these 4 connections are shared by all the 4 multiplexers that are connected to the Arduino. Every multiplexer can control up to 16 buttons, and if you want to control more buttons, then you have to cascade more multiplexers in a row. Again, thinking of the upcoming XRP, there will be more buttons to control. And for every multiplexer, you need 1 additional pin as a data connection. On the right, you can see I have called this input multiplexer data. And now add a new multiplexer, here the digital input multiplexer, and I'm calling the first multiplexer IMP9, input multiplexer number 9 in my complete setting. Up here you will find the values that we have talked about before, and I'm now configuring these. S0 should be pin 12. Here we have pin 11, 10 and pin 9. We can't configure because it is down here, but the data pin for the first multiplexer should be pin 8. And now I can use pin 9 up here. So if one of the pins isn't available, just switching between 2 devices, and then it has updated here. So 12, 11, 10, 9 is right, pin 8 is a data, and yeah, we have a 16-bit multiplexer. Yeah, there is one special thing here concerning multiplexers than at the output shift registers. For the multiplexers, you need 1 device for each multiplexer you are connecting to your Arduino, because you have to set a data pin for this. For the output shift registers, you only need this 1 device here, and you can then connect 1 up to 4 of these registers. So we are adding a new multiplexer. This is input multiplexer 10, and you can see the pins up here are grayed off, so I can't make any changes here because they are set in the first of these multiplexers here. This is, I would call it, the main multiplexer of these. And if you want to change these, you can go there directly to this multiplexer, or click here, go to pin settings, and it is jumping to the place where you can change them. But in our case, we just have to set the next data pin, and this is pin number 7. So again, next multiplexer, IMP11 with the pin 6, and another one IMP12 with data pin 5. So now we can control LEDs and buttons. The last missing devices are the 2 rotary encoders of our EFIS panel. Before I start with the configuration in MobiFlight, let's have a short look again to the configuration sheet so that you understand what I'm doing. Here you can see the 2 encoders, which are documented here by 4 lines in my configuration sheet. Every encoder needs 2 pins on your Arduino, a left and a right pin, and I'm connecting these encoders to the Arduino directly and not via a multiplexer. I even don't think that multiplexers can support encoders. I haven't tried this, but I'm saving so many pins now by using shift registers and multiplexers, so I think I can use those 4 pins here for the encoders. You see here again what it means to use a 16-bit offset. I have written down the 2 offsets here that are used by the encoder. And something you will see in a moment is my way of naming the devices. Every device that needs more than 1 line in my configuration sheet will get a name that is a mixture of the configuration line numbers here. For example, this encoder includes the lines C42 and 43, so I will name the encoder C42/43. I'm always writing down the first and last line of a configuration here. So I'm adding an encoder. So left pin is pin 14 and the right pin is pin 15. I'm not really an expert in this type here. I have mostly chosen, I think, this one here. I think it worked out really good for me. So the name of the encoder, and now it comes, it is C4243. Oh, and another encoder, C4445 type, and it has the pins 16 and 17. And these are all the devices we have to configure for the whole glare shield and EFIS panel. And if you remember, there are 33 connections at this EFIS panel here. So using shift registers and multiplexers keeps your configuration small and easier to handle. Uploading the configuration now to the Arduino. What I'm now doing is going through my configuration sheet and making a new button configuration for each line here of the sheet. Giving it the name I've chosen here in the first column, selecting the pin or the pin on a multiplexer where a device is connected to, and entering the offset and hex value. Stupid but easy work, but at the end you will come out with a working EFIS panel if everything goes right. So let's make our first configuration. But as I have said, I have rewired my Glarewings and I have to change some already existing configurations here. This is not directly concerning to the EFIS panel, but it is a result of my rewiring and restructuring or my Arduino structure here. And I think it might be interesting for you as well. So we have here in the Input Configs tab some C configurations, C9 to 11, which are the 3 buttons of the Glarewing. C9, when I look to my configuration sheet, is the fire warning push button. This will get a new name now. This will be C46 in the future. And we tell MobiFlight where the device is connected now. So it's connected to the input multiplexer 11 and there on pin 1. And what we do for all the buttons, we choose our action type, FSU IPC offset, and you enter the offset that I want to use there, 66C6. If you want to know more about offsets and which offsets you can use, watch my introduction to MobiFlight and FSU IPC. There I'm talking about all the offsets that can be used. So, and the hex offset will be bit number 1. So when the button is pushed, I will send a 1 value. Now we can copy all this here to the on release state, insert it, and the only difference is when we release a button, we send a 0. So now C10, which will be the master caution button and will be called C47 in the future. Also connected to the input multiplexer 11 and there to bit 2. I paste the configuration in because the offset is the same, just the bit is a different one. And the same for the on release state. And last button from the Glarewing is the C11, which is now C48, the recall push button. Now we have already reconfigured the buttons of our Glarewing. And now to the first button of the EFIS panel. Again, a button, same structure. Again for you, so that you can follow up what I'm doing here. The new C9 configuration here. I'm starting with a new configuration, C9, C09. Now MobiFlight needs to know where this button is connected to. It's the Arduino C, and you can choose the device again, or we can use the scan for input button, click it, and then clicking the mince reset push button, which I have done now here on the EFIS panel, and it sees that the switch is connected to the input multiplexer 9 on the input 0. What I have found out, this works good for push buttons. With rotary switches, it is a little bit difficult because when you move a rotary switch, then you will receive two signals, release state for the current state where the rotary switch is set to, and on press state for the new position of the switch. And I think in most cases it receives then the release state of the old position, and this is the position that you don't want to have at this point here. So I think the scan function is good for push buttons, but only for those. And in my case, I have here my documentation list here. I can follow along. So, but it is right here, input multiplexer 9 position 0 as expected. And again, we will set an FSU IPC offset. And which offset? This I have documented here, 5369, 5369, and the hex bit is the number 3. And when it is pressed, I will send a 1. I copy again this whole setting here, and the on release state, I paste it in, change the set value to 0. This is all I can show you for these buttons here. I will go through this long list of buttons, and then we come together again when I have to set up the encoders. I have already prepared those two configurations in MobiFlight because they are nearly similar to the configurations of buttons, and so you don't have to look the whole process again. As I have explained before, here is my method to naming those configurations, and we will have a look into the first one of these here. Like before, I have defined the Arduino where this device is connected to and the name of it. It is the same name as the name of the configuration. And now comes a difference compared to the configuration of buttons. A button has only two states, the on pressed state and on release state. For an encoder, we can define 4 states here. You can see it here, left and right. In most cases, I'm using these for lowering or increasing a value. And In addition to this, we have on left fast and on right fast, so that you don't need to turn and turn and turn and only make small changes of the value, but when the software recognizes you are turning the encoder fast, then you can make bigger steps. The action type is an EFIS UIPC offset, like always, and I have entered the starting offset here. Keep in mind, and this you have to insert here, I'm using 2 bytes here, and so the software knows that it has to use the following offset 2. When I'm turning left, I want to lower the value, and so I'm entering here in the set value field a -1. And for lowering the value faster, I'm entering a -10. On right, most inserts are the same. The only thing you have to change is the set value. This is here a 1, and on right fast a 10. And a similar configuration is done for the second encoder, just with a different offset. After all this configuring, we are ready for the final test with the hardware panel. You can see the EFIS panel here on my desk. I have prepared running in the background. You can see up here an instance of Prosim display to control all the switches. Yes, and now I can click run in MobiFlight. Oh, and let's test some of the switches. Oh, and let's start with the minimums here. Baro and radio. This is working. The baro of 2 inch and hectopascal. It's working. We have the VOR to ADF1 off VOR1. This is working, and the other one ADF2 off and VOR2. Yes, that's working. Here VOR app, VOR, yes, map and plan, and the distances. So there it is. 5, 10, there's 10, yes, 20, 40, 80, there's 160, and last one, yes, these are working. The push buttons, we aren't able to control the push buttons here, so we have to look to Prosim here in the throttle MCP section, you remember, and at EFIS 2. So what do we have here? The airport. Yeah, you can see here at airport it goes to pushed. So this is working, the command is coming. Baro standard. Yep, there it is. EFIS center. There it is. And data. There it is. Here. No, pushed. Yes. FPV. There it is. Minimums reset. There. And meters. Here pushed. It works. Some others here standard is still missing. There. Yep. TFC down there. Yeah, it is working. VXR there and waypoint. So, yes. And for finally testing the encoders, I have brought up an instance of Prosim displays, and here is shown the first officer PFD, which will be controlled by the EFIS that is connected to the Arduino C. And by turning now the Baro encoder here to the right, you see I increase the pressure value here, and to the left I'm lowering it, and I can also do this fast, and you can see then it goes up faster. And for the minimums, I'm turning it to the right, and you can see there the value is increasing and also fast. and when I turn it to the left, I lower it. And so the EFIS is completely configured. And this concludes the build process of the EFIS panel, a very compact device that you can also build when you are just a desktop pilot. You can build this, put it on your table and connect it via MobiFlight to your simulator. As I have said in the build video, you can find all the needed files for cutting out and engraving and 3D printing this panel in the member section of my website. And you can also find the configuration sheet for download there. And I have to move on in my cockpit building process. There are some more devices to build. And if you don't want to miss those upcoming episodes, then subscribe to my channel to stay informed about any upcoming new video from me. And I hope we'll see us soon back on the flight deck.